Welcome to Let's Talk Micro.
Hello, everyone. Welcome to another episode of Let's Talk Micro. As always, I hope you had a great week. Remember that Let's Talk Micro is available on Apple Podcasts, Spotify, TuneIn Radio, Amazon Music, Overcast, Google Podcasts, Pandora. Wherever you listen to your podcast, you can find Let's Talk Micro. I am also on Instagram as Let's Talk Micro, no apostrophe, and on Twitter as Let's Talk Micro 1. So go ahead and follow, give feedback, any podcast suggestions, any topics. I always like to post pictures of organisms, and I always like to give updates as to when the next episode is coming out. So on the last episode, I went over Group B strep testing. If you haven't checked it out, go ahead and do so. There's a series, episodes 36 and 37. On the first one, on 36, I go over the organism, actually. I talked about hemolysis, media, and then on the next episode, I go over testing. So I talked about 3 different tests that we use for Group B strep. So I talked about Todd-Hewitt broth. I mentioned how to work up the culture. You use the Todd-Hewitt broth with blood agar, and then you keep that blood plate for 2 days looking for Group B strep. After 24 hours of inoculating your plate and your Todd-Hewitt broth, you go ahead and if there's cloudiness on your broth, you subculture that to a blood agar plate, and then you keep that plate for 2 days. After that, if no Group B strep is seen, the culture is negative for Group B strep. So I talked about the PCR methods that we use. I mentioned the GBS LB, which is Group B strep limb broth. So you inoculate the broth, and then after 24 hours, you run the PCR test. And then I mentioned the GBS PCR test, where you can actually, with that PCR test, the patient is typically in active labor, and you go ahead and from the swab, you perform the PCR test. So this is not an enrichment process like inoculating on Todd-Hewitt broth. You, in all likelihood, are going to have to confirm a negative result. So if you haven't checked out those episodes, go ahead and do so. Great information about Group B strep. Remember, it's Landsfield classification B. It's beta hemolytic, of course, catalase negative. It types for the latex, it's latex B positive. And it's a very serious organism. It is seen in, it causes neonatal meningitis and sepsis. And it has been discovered that in most of these cases, in a high percentage, the mom is colonized with this organism. So this is why during gestation, she goes to the OB. A vaginal rectal swab is collected, and then we screen for Group B strep in the lab, either by doing the standard culture or by doing like a GBS LB or any of the other molecular PCR methods. But the most important thing is we screen for it, and then if we actually find it, if we recover from culture, then the patient needs to be treated. But susceptibilities are not done unless the patient has an allergy to penicillin. So go ahead and check out those episodes and leave any feedback on social media if you have any. So today is an interview episode. I always love these. I get to connect with other professionals in the microbiology field. So if you recall from January, there was an episode that I published about Staphylococcus argenteus. It was updated. It was published on January 13th of this year, and it was titled "Talking Staphylococcus argenteus," where I had Dr. Schutz and Dr. Patel from the Mayo Clinic, and then came to talk about a study that was published in the American Society of Microbiology, in one of the journals. They came to discuss that article about how there was a study done where some isolates that were initially thought to be Staphylococcus aureus, they ended up being identified as Staphylococcus argenteus. And in that episode, if you haven't checked it out, go ahead and do so. So we talked about how similar, this Staphylococcus argenteus, it's to Staph aureus. It is catalase positive, it's coagulase positive, and it was identified, via gene sequencing. So it is very similar. It even has some virulence factors. There's some evidence of it being a colonizer. So with the regular test that we do in the lab, it's very hard to identify it as Staph argenteus. In fact, nowadays, it's been identified via Malditov. The Bruker was the first one to have it. And I did speak to a representative of bioMérieux, and it's going to be added to the regular Vitek MS database later on this year. So that's some great news. So it makes you wonder sometimes, you are on the bench, you have an organism that looks like Staph aureus, right? Beta hemolytic. You go ahead and do your catalase is positive, you do your coagulase is positive, and then you typically will presumptively identify it as Staph aureus. Well, what if it isn't? Right? One of the things that was discussed in this episode was that the fact that, I did mention that the virulence factors, and I talked about the evidence of it being a colonizer. But however, this particular species, it doesn't have the staphyloxanthin gene, so it doesn't have that golden color that Staph aureus has. This gene has, confers that pigment. So Staphylococcus aureus is yellow. So this one is argenteus because it's silver looking. So it's the silver staph. Well, in this interview that I'm performing now, that it's gonna be, it's gonna be in this episode, there was another species that was initially thought to be Staphylococcus argenteus. And by gene sequencing as well, it ended up being another species. And since it was discovered in Singapore, it was called Staphylococcus singaporensis. So there were 6 isolates that ended up being called Staphylococcus singaporensis. So not a lot of information. We don't have a lot of information right now about this organism, but so far, it points that it might not have any virulence factors, or if so, maybe very few, not many. And then this one does have this, seems to point to the direction that it has the staphyloxanthin gene. So it's gonna look more similar to Staph aureus than argenteus, does. So it is some great information. It was a great discovery. This article was published in the Microbiology Society journal from England. So in this episode, we have Dr. Jeanette Teo. She is a scientist at the National University Hospital in Singapore. So I extended an invitation to the podcast and she accepted. And then she came on board and we talked about Staphylococcus singaporensis. We talked about this discovery, virulence factors. We talked about the staphyloxanthin gene. So let's go ahead and check out the interview. So last month there was an episode where there was an interview where we talked about the Staph aureus complex and we talked about Staphylococcus argenteus. So today we have a new article, and which is titled Staphylococcus singaporensis, a new member of the Staphylococcus aureus complex isolated from human clinical specimens. This was published in the International Journal of Systematic and Evolutionary Microbiology, or the Microbiology Society. So today with us, we have Dr. Teo to discuss this article. Dr. Jeanette Teo, welcome to Let's Talk Micro.
Hi, Luis. Thanks for having me.
You're very welcome. So let's start with an introduction. What is your occupation?
So I work at the National University Hospital in Singapore. So this is at the microbiology unit. It's a fairly large hospital. It's like 1,000 beds with acute care. So I'm a research scientist. So essentially, I just take care of all the molecular diagnostics, anything to do with like the DNA, the RNA, sort of molecular aspects of microbiology that is used for diagnostics in the routine lab.
Okay. So let's go ahead and start, like I mentioned on the intro. So, there's a member, Staphylococcus argenteus, which is part of the Staphylococcus aureus complex.
Yes.
So now this is a new member, which is Staphylococcus singaporensis. So for the audience, can you do a summary of the article?
Yes. So actually this article started off with we actually initiated this study about 2 years ago, but then because of the COVID and whatnot in between, so it got a little bit delayed. So essentially we were looking at Staph argenteus and Schwetzeri. So these are complex members. We looked into that because Staph aureus is quite famous. So and then we wanted to know what these other sort of sister isolates were doing in our sort of clinical population. So we thought we would collect these argenteus and Schwetzeri isolates. And lo and behold, so we did all the genome sequencing, and then we realized that the 43 argenteus that we had collected, out of these 43, 6 were actually not argenteus and not Schwetzeri as well. So they turned out to be singaporensis. So which was I think it's a serendipitous thing. So it's a nice surprise.
Indeed. So just to check, and then it's also on the article. But so these organisms that were initially identified as Staph argenteus or Schwetzeri by Malditov?
Yes. So using the MALDI, a large number of them, I'd say about 90%. So you will get argenteus hit. Occasionally, aureus might pop up. Schwetzeri, not common, but yeah, it is suggested on the MALDI. Yeah.
So as far as you know, any of the instruments that are routinely used in the clinical microbiology lab, can they identify it?
No. So MALDI now will be the mainstay for identification. We hardly ever do any of these biochemical tests that you would have done, decades ago for staph. So using just the MALDI, no, we will not be able to identify singaporensis. And even having said that, I think probably trying to differentiate argenteus and Schwetzeri might also be a little bit not that altogether that accurate as well. So yeah.
Yes, definitely that's one of the challenges that there was with argenteus, and I see on the article as well that it will it will agglutinate with the staph latex, so it basically presents itself as Staph aureus, beta hemolytic as well.
Yes. So so biochemically you would not be able to differentiate them. So none of the if you're using a biochemical test like the API or the VITEC, that's not going to help you in any way.
Definitely. One of the things that as I was reading the article, I saw the virulence factors on this strain. I mean, are there any of this, versus, because there was discovered that on Staph argenteus there are some.
Yes.
Are there any on Staphylococcus singaporensis?
So what happens is, so with the whole genome, so we match, I mean, once you have the whole genome data, so you look at the virulence factors in singaporensis, and that's largely based on looking at Staph aureus virulence factor database. So whatever we know, it tends to be about Staph aureus. So argenteus may have new virulence factors which are a little bit peculiar to them. It's just that we don't know about them yet because we haven't looked enough into detail and we don't have that many isolates. But I would say overall, when we look at the virulence content, I'd say it does seem to have a little bit of a lower prevalence for virulence genes, so probably less of like the SPA genes and the capsular proteins. Don't see any of the leukocidin genes and things like that. So perhaps that suggests it might be a little bit less virulent.
Okay, and one thing that also caught my attention was because I know that when I was reading about argenteus, that let's talk about the Staphylococcus.
Yes, yes. So argenteus is known as, okay, so Staph aureus is known as the golden staph because it produces that golden, that yellow sort of pigmentation. So you see that quite nicely on the plate. And argenteus doesn't, so they don't produce staphyloxanthin, so you don't get that yellow pigmentation. So they are also called the silver staph because argenteus or silver staph. And so we would say singaporensis is like the second sort of yellow staph aureus because they do look yellow on the plate as well. So in silico, when you do the genome prediction, they do have the operons that actually code for the staphyloxanthin gene. So that suggests to us that yes, so they would actually be producing staphyloxanthin.
So basically, definitely it could definitely look like a
Oh, definitely.
Staph aureus, because
Yes,
that's one of
yeah.
the things. As I did more research with the argenteus, and I work in a clinical lab, so sometimes I see what's a Staph aureus, and then you look at your plate and it looks a little silver, so it makes me think. I mean, we don't have yet, our MALDI-TOF cannot identify argenteus yet,
Yeah.
but now this one can actually, it's even yellow, so it's
Yeah.
even more similar to Staph aureus than that argenteus can be.
Mm-hmm. Yes.
Okay, and then as far as these samples, what was the source? I mean, was there any particular patient population?
Right. So all these were clinical samples. So there wasn't any particular patient population. So these were just isolates that were coming in for workup. So we had 6 isolates. 4 of them came from skin and soft tissue infections. 1 came from a gallbladder specimen, and the other from an MRSA screening. So, which again suggests that it's definitely associated with disease, just like Staph aureus. Right now, we think singaporensis, well, we haven't done the longitudinal large-scale study, so but we think that it probably might be in the Staph aureus population at about maybe 3%. So actually, if you're looking at Staph aureus as a whole, maybe about 3% of them will actually be singaporensis. So yeah.
Okay, and then the other question I have is definitely, we know that Staph aureus it's a colonizer, and
Yes.
there are articles that say that our argenteus points to that as well.
Mm-hmm.
As far as I mean, we don't have that much information about this organism yet, but is there any evidence of colonization?
Yeah, so again, like you said, we don't have enough data yet. So and we don't haven't done any of these time studies to see if they actually stick around or if they drop off or whatever. So, but yeah, I'm going to go with they're going to behave just like the other staffs, and they will be colonizers as well. Yeah, very good chance that they will behave like the other cousins.
And also from the article, I know that it seems that as far as susceptibilities, with the ones that were tested, it was fairly susceptible versus argenteus.
So it doesn't seem to have the methicillin resistance and all the other drug resistance mechanisms that might come with Staph aureus. So, but again, who knows, with time, with antibiotic pressure, that might actually happen. So
Yes, definitely, and as we know more, definitely, and of course, that way, once all the instruments are up to date and they can identify, and of course, then we can think about assigning breakpoints and things like
that's
that.
true. Yeah, but first we need more isolates.
Yes, we definitely do. Are you currently trying to work to see if maybe you can discover some more?
Yes, that's what we're trying to do. So we'll probably gather up the step that have been identified on Maldi as argenteus, run the PCR screen. So yeah, hopefully we'll have some genes that are just particular for singaporensis, and that might help our PCR. So, and then from there we'll just hopefully have some money to do whole genome sequencing.
Yes, definitely. It's very, so this is a very interesting, I mean, discovery. Not too many, people in the field like to have actually a new species. That's something that's very exciting.
Yes, yes. Yeah. So like I say, serendipitous.
Yes, it's a great, especially now as molecular makes such a great advances in our field. So now we're definitely seeing more and more, more organisms, more, sometimes the names are changing, and
Yes,
so
absolutely. Definitely. Yeah.
so this is something definitely good for the audience to keep in mind, especially the laboratorians, that we have these organisms out there that just to keep them in
Yeah.
the back of your mind. And like I mentioned before, now argenteus is actually going to be added to
Great.
the
Yes.
other the Vitec MS database, which is a very popular one here in the US. So that's good. We should be expecting to be seeing more argenteus soon. So Dr. Teo, is there anything else that you want to tell the audience about this
No,
article?
but I think for those of us who work in routine sort of clinical lab settings, so don't think it'll get boring. So there's actually a good chance you might actually, discover a new species. Yeah, sometimes it just takes a little bit of intuition and well, definitely the whole genome sequencing technologies help. But yeah, there is definitely a lot of undiscovered novel species out there. Yeah, we've seen it.
Yes, definitely some, we are in some exciting times with all the technology that we have. So like you said, definitely, it's not boring. So those of you that are just hanging there, and maybe one day you'll discover one yourself. All right. Well, Dr. Teo, I want to thank you for taking the time to come in on to Let's Talk Micro. I appreciate, this information. This was a really, good information for us laboratorians.
Yes, thanks, Louis. Thanks for having me. It's been great sharing this article with you.
All right. Thank you so much.
Thanks.
And then, my dear audience, it's the end of this episode. I hope you enjoyed listening to this wonderful interview. As always, I enjoy sharing this information with you. Continue bringing that passion to what you do. That's always so important, to stay motivated, educate yourself, and doing your very best at what you do. All of you microbiologists out there, thank you for your amazing work, and all the healthcare workers and everyone that's working so hard. So as always, stay motivated, stay safe, and of course, continue talking micro. Until the next time, bye.